Hello, welcome to another video. This one's, I guess, a little bit of a less happy one. I've archived all of my Go projects. It's not clickbait. I'm going to walk you through why I wrote them all in the first place, and I don't know, maybe my thoughts on the Go programming language in general. You already know that. Okay, so the background on this is I, a long time ago, wanted to write, actually, this is quite the bit of a rabbit hole. I wanted to write a linter for Docker files, and there is one official Docker file parser. It is written in Go for the Docker project. And I mean, there are many other re-implementations, but they are all slightly different or buggy or different behaviors, and I wanted the exact behavior from the official one. And so initially I started writing my linter in Go, and I just felt like the ergonomics of the language weren't as good as I wanted them to be. Not saying Python is better, but I had a lot more familiarity, and so I thought, why not write one in Python, but still use the official Go parser? So I looked into how to make a Go CPython extension, and I don't even know where this is going to be. Somewhere in here. And I managed to make a where is it? This one. I managed to follow this blog post, which showed how to make a Python module in Go 1.5 way back in 2015. So this was a very, very long time ago. And I followed their example and was able to get something working that also worked in PyPy and Python 3, Python 2, all at the same time. And so I wanted to generalize this idea. And so I wrote setup tools Golang, which is a setup tools extension that allows you to write CPython extensions in Go. It looks very similar to how you would write a C extension. Of course, you have to tell it a little bit of extra information such that it can build the Go root properly and build all the things together. But it basically mostly just worked. Yeah, there's some weird errors with some strange stuff that can happen sometimes, but for the most part, these worked and worked well. And oddly enough, they worked on all the main platforms. And in fact, I think it ended up working on 64-bit Windows as well. Anyway, this all worked great, and it worked all the way back till Go from 2015 and was working well. We'll get to this in a second. I actually did a longer video on this. If you want to search my channel for this, you'll find the video where I go over how I made this happen. Anyway, I did all that work. I got a setup tools extension working, and then I wrote a binding for the Docker file parser, and that all worked great. And then I burned out on the project and didn't actually end up writing the Docker file linter. So I wrote all of this infrastructure mostly to kind of get a good feel for how Go works, and then play around with some Python stuff. And I actually changed the type system of Go forever as a side effect of this. I was trying to get this to work with, let me get there, Golang, Go. I was trying to get this to work with both PyPy and CPython, and PyPy and CPython have slightly different type defs in how they declare their CPython types. And at the time, find it through this. At the time, I think I made it as a pull request. Oh, hope was a commit then. That's way more annoying. At the time, the type defs were different, and I can't get to it either. I'm trying to get to the contributor graph so I can find my contributions. Do this. See that I made type defs in CGO treated the same. So this was so I could use PyPy and CPython for one single source. And actually this made a whole bunch of types now aliases where they previously were new types. I don't know what the word is in Go, but there's two types of aliases in Go. And one they're treated equivalently, and the other one they're not. And this switched type defs from being not equivalent to equivalent, basically by doing this. Yeah. Cool. So I changed the type system of Go. Anyway, I wrote all this infrastructure, everything worked great, and then about a year ago, I noticed that the builds in my example repository started being really, really flaky. Let's see if I can actually even find them still, or if they've gone with archives. Yeah, here's a great example. They started being extremely flaky, and mostly only on Intel Mac OS, and they would always fail with a SIG abort, that's exit code -6. And actually, I've reproduced that here. I have a Mac Mini literally just so that I can test stuff, and you can see that, yes, We get fatal Python error aborted. And when I saw this, I was very busy with other stuff and I wasn't really thinking too much about it. And I was just like, whatever, it's just Mac OS. Maybe Mac OS is just flaky, blah, blah, blah. And sort of ignored this error, let it just sit in the background for a while. However, every time I updated this repo, there was a pretty good chance that this was going to fail in this way, and I wanted to retry it a bunch of times. And at some point, I'm like, maybe there is actually something wrong here. So let's try and figure out what's wrong with this. And I poked around on my own machine, and it was very, very reproducible here. Oddly enough, it seems to flake less often in GitHub Actions than locally, which is usually the opposite of the experience that I have. But it was very, very consistently failing locally. And I was like, I know this didn't happen before, and at some time it changed. And that usually tells me that something in Go changed, and I can probably bisect to find the answer for this. And so that's exactly what I set out to do. And it turns out Go is actually very easy to build and very easy to bisect. This is it. This is the entire script that I needed to bisect problem. Basically, Go has a single bash script that will allow you to build the entire thing. So clean the repository, cd into the source of this is just how Go's build works. Literally one line, which is great. Add the freshly built Go binary to the path, and then run a little reproduction. Spoilers, this is actually not my reproduction, but someone else's, after I managed to find an equivalent issue in the issue tracker, and they had a much simpler reproduction than building a Python extension and running PyTest in a loop until it fails. Theirs is just a little C binary, a lot easier. But basically bisected this down and was able to find a commit. If you haven't seen my video on Bisect, just search my channel for it. Basically, Bisect allows you to find when some regression occurs, and it basically starts with some range of good to bad and then tries the thing in the middle and eliminates half the commits at a time, a bisection, to get to the failing commit. And after running the bisect, I was able to identify the commit that was the problem, and also the issue where the problem is. Runtime, panic when executing from multiple C shared libraries. Basically, if you have more than one shared library in the process, the Go runtime does not work. It crashes in weird ways, and that's exactly what I was seeing here. This person also saw the same thing. This is the minimal reproduction that they had, and I managed to reuse that same thing in my bisection here. We scroll down a bit more. We'll ignore the happen here. Somewhere. Where did I start talking in this thread? Here we go. I did bisect it down, and I ended up finding the commit which caused this to regress. Now, normally I think a regression would be treated as a problem and reverted, but Go maintainers were like, no, we never really intended to support this. It's just been working for a decade, sort of accidentally. That's the way things go. But anyway, the actual change set that I narrowed it down to is a performance hack. It's literally just to improve performance of CGO. And so it's just sort of sad to see these projects all die due to a performance improvement that, breaks. Yeah, here's my bisection, same thing I ran. Basically breaks something that was really cool, but now is sort of infeasible. The result of this is you can only have one Go binary or Go shared library in a single process. You can't have multiple of them, and so it kind of kills the idea of using Go as a programming language to write Python extensions. I can't think of any other language that would have this limitation. Basically, the idea is that they have some fixed global state between the Go runtime instances that if you have two of them, they don't really know what to do with each other, kind of overwrite each other's global. As far as I can tell, this shouldn't happen, and they're doing something weird with like some fixed offset or some like constant location in memory rather than having a named symbol that gets relocated. Because as far as I can tell, the way Python's import system works is it uses libdynload to dynamically load a shared object, and it uses this rtld now, which that part's not important. This is the part that's important, rtld local, which tells the dynamic or the dynamic loader where it should or how it should handle global symbols and how it should sort of namespace them. It doesn't actually namespace them, but they get relocated different to each other, and they aren't in the global scope. So like two extensions that link libSSL, they can have their own copy of it without interfering with each other. Even though OpenSSL is going to define the same function names and the same C symbols, each of these shared objects would have get their own copy. Not exactly like that, but you can kind of think about it like that. And so despite that, and despite Python's import system trying really hard to make this possible, Go is like, lol, no. Skeptical that it ever worked, may have accidentally worked, and they're not going to fix it. But anyway, so that's a means to an end for maintaining Go things, because literally all I was doing was, the only reason that I was doing this was to expose it to Python, but if that is intentionally not supported, then such is life. Anyway, a bit of a bittersweet video. Hopefully you found this interesting. If there are additional things you'd like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.